Welcome to the unit on functions and graphs, review exercises. The objectives for this session are to review previous topics through exercises, namely change the subject of an equation, simplify mathematical expressions, sketch equations, and find values of a function at specific points. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Before we tackle review exercise 1, let's take a look at the subject of an equation. The steps we need to take in order to make y, for example, the subject of a simple equation, are firstly, rearrange the equation so that all the y's are, say, on the left-hand side, and the rest are on the other. Next, factorize the left-hand side if necessary or possible so that y becomes a factor. And finally, divide by the other factor in order to isolate y. So let's now take a look at review exercise 1. Part A asks us to make y the subject of 2x equals 8 minus 5y. So let's solve this. We're going to add 5y to both sides in order to bring the y's to the left-hand side. So here's our original equation, and here's 5y added on to both sides. And so tidying up, we have 2x plus 5y on the left-hand side and 8 on the right-hand side. We've removed all the 5y's or the y's from the right-hand side. Now we're going to remove the x's from the left-hand side, or rather we're going to get rid of any term which doesn't involve a y. And in particular, in this example, it's 2x. So we're going to subtract 2x from both sides. So here's our equation, and here's 2x subtracted from both sides. And we're left on the left-hand side with 5y as shown, and on the right-hand side we have 8 minus 2x. Now 5y, of course, is already factorized, so all we need to do in our final step is divide by 5. And so dividing by 5 allows us to isolate y, which gives us y equals 8 minus 2x all over 5. And now for part B. We're required to make y the subject of q equals 3y minus 7x all over 4. So let's solve this. We're going to begin by rearranging the equation so that all the y's are on the left-hand side and the rest are on the other. So the first step we're going to take is getting rid of that fraction. So we multiply by 4 on both sides, as shown, to give us 4q equals 3y minus 7x. And then we add 7x to both sides. This allows us to get rid of the x's or the non-y terms on the right-hand side. You might be thinking, well, we were required to put y on the left-hand side, but all we simply need to do is swap sides. So let's carry out this step. And when we do so, we have a 3y, we've put that on the left-hand side, so 3y minus 7x plus 7x equals 4q plus 7x. And we factorize, but of course the left-hand side is already factorized. We have 3y. So we simply need to divide by 3 in order to give us y equals 4q plus 7x all over 3. And now for part C. We're required to make y the subject of the equation 3x minus 7y equals 8 minus 6xy. This is a step more complicated than the other equations, but it's still a simple equation. So let's solve this. We're going to again begin by rearranging the equation so that all the y's are on, say, the left-hand side. And we're going to do that by adding 6xy to both sides. That will allow us to bring over all the y's onto one side or onto the left-hand side. So here's our original equation, and here's 6xy added on. And tidying up gives us 3x minus 7y plus 6xy equals 8. And here's our equation, and we're going to take 3x from both sides because we're going to bring over all the non-y terms onto the other side. So here we've taken 3x from both sides. And this gives us 8 minus 3x on the right-hand side. 3x minus 3x disappears. And so we're left with 6xy minus 7y on the left-hand side. So only the y terms. And now we factorize. So 8 minus 3x, of course, stays as it is. We're factorizing the left-hand side. And factorizing gives us y times 6x minus 7. And so finally, we want to isolate the y, so we divide through by 6x minus 7. So we have that y equals 8 minus 3x all over 6x minus 7. Before we take a look at exercise 2, let's take a quick look at how we simplify expressions. Essentially, when we're simplifying expressions, we're collecting like terms in which the variables are the same together. So, for example, in this expression, 2a plus 3b minus a plus 5b, if we collect all the like terms together, so 2a minus a then becomes a, and of course 3b plus 5b then becomes 8b. In other expressions, we may need to expand brackets and then simplify. We may also need to perhaps simplify fractions and then collect the like terms together. So let's now take a look at exercise 2. Part A asks us to write 3x minus 5 all squared plus 3 in its simplest form. So let's solve this. Let's expand the brackets first. In order to obtain 9x squared minus 30x plus 25. And of course plus 3 as well, which is part of the expression. If we collect the like terms together, we can simply add the constants in this case. Everything else stays as it is. So 25 plus 3 becomes 28. And now for exercise B. We are required to write 1 over 3 times 5x minus 2 minus 7 in its simplest form. So let's solve this. Again, we expand the brackets in the numerator to give us 1 over 15x minus 6 minus 7, which simplifies to 1 over 15x minus 13. And now for part C, we have a numerator in a fraction involving a fraction and a denominator in this fraction involving a fraction. And because we're dividing through by x plus 3, top and bottom, when we solve this, let's multiply the numerator and denominator by x plus 3. So we have x minus 2 minus 4 times x plus 3 in the numerator and x minus 2 plus 5 times x plus 3 in the denominator. And tidying up gives us x minus 2 minus 4x minus 12 all over x minus 2 plus 5x plus 15 in the denominator. And tidying up gives us minus 3x, we've collected the x terms together, minus 14, we've collected the constants together, all over 6x, again we've collected the x terms together, plus 13, we've collected the constants together. And this is our simplified expression. The next exercise asks us to sketch y equals e to the power x. Before we do that, let's take a look at some exponential functions of the form f of x equals a to the power x, where a is a constant. We're also going to take a look at the derivatives, k times a to the power x, for that particular value of a. We've given here some functions, or some exponential functions, and their derivatives. So f of x equals 1 to the power x, of course, is just the constant function, and the gradient function is simply 0. F of x equals 2 to the power x, the gradient is as shown, and likewise for f of x equals 3 to the power x and f of x equals 4 to the power x. Let's now see how these functions and their gradients interact with one another. So if we take a look at y equals 2 to the power x and its derivative here, notice that y equals 2 to the power x is above the line for dy dx. Here's y equals 2 to the power x, and here's dy dx, or f dashed of x. For y equals 3 to the power x, or the other notation f of x equals 3 to the power x, we have the derivative as shown, and notice this time the derivative is above the function. Here's y equals 3 to the power x, and here's f dashed of x, or the derivative. And finally y equals 4 to the power x, and its derivative. Notice again the function is below the derivative line. So here's the function, and here's its derivative. So if we look at solving exercise 3a, let's begin by looking at the differential. F dash of x equals k times a to the power x for k constant. Notice that as a increases, k increases. Between a equals 2 and a equals 3, there exists a value e such that f of x equals e to the power x equals f dash of x. So there's a point at which the derivative and the function are both equal. And the value e is approximately 2.71828, and it's irrational. Here's a sketch. The key points to note for this function, as we mentioned earlier, are that the function and the derivative are the same for all real values of x. Also, when x equals 0, we have y equals 1. As x tends to infinity, y tends to infinity. And as x tends to minus infinity, y tends to 0. Now let's take a look at exercise 3b. We are required to sketch the function y equals x plus 3 times x minus 1 times x minus 2, indicating the points where the function crosses the axes. So let's begin. When y equals 0, we have that either x equals minus 3 or x equals 1 or x equals 2. So these are the points at which the function crosses the x-axis. When x equals 0, we can plug x equal to 0 into this equation and obtain y equals 6. So this is the place where the function crosses the y-axis, as shown. What happens as x tends to infinity? We have x plus 3 tending to infinity, x minus 1 tending to infinity, and x minus 2 tending to infinity. So of course f of x tends to infinity also. As x tends to minus infinity, we have x plus 3 tending to minus infinity, and also x minus 1 tending to minus infinity, and x minus 2 tending to minus infinity. So f of x tends to minus infinity also. So let's incorporate these facts into our graph. It's going to look something like this. And here's our graph of y equals x plus 3 times x minus 1 times x minus 2. In the next exercise, we are required to sketch the cosine curve. Remember that graphs of sine, cosine, and tangent are periodic. This means they repeat themselves after a certain interval. Let's now take a look at exercise 3c. We are required to sketch y equals cos x for x greater than or equal to minus 360 degrees and less than or equal to 540 degrees, and label any points where the graph cuts the x or y axis. So let's solve this. The graph of y equals cos x repeats every 360 degrees and crosses the x-axis at, for our exercise, and we can extend this to other exercises, minus 270 degrees, minus 90 degrees, 90 degrees, 270 degrees, 450 degrees, and so on. So essentially every 180 degrees. The maximum of the cosine curve is 1 and the minimum is minus 1. So here's our curve. Here are the points at which cos crosses the x-axis. Here are the points at which cos is maximum, so at minus 360 degrees, at 0 degrees, at 360 degrees, and so on. And here are the points at which cos is minimum, so at minus 1. or equal to minus 1, so cos x equals minus 1 when x equals minus 180 degrees plus 180 degrees, and so on. So here's our curve. And finally, for exercise 4, we have that if f of x equals 2x squared minus 4x, find the values of f of 3, f of 2, and f of minus 2. So this is simply an exercise in plugging in values of x. So if we solve exercise 4a, we plug in x equals 3 into the equation, as shown here, to give us that f of 3 equals 6. And for part B, we need to plug in x equals 2, as shown, to give f of 2 equals 0. And finally, for part C, we plug in x equals minus 2. As shown, to give f of minus 2 equals 16. This brings us to the end of this session. If you have understood its contents, you should be able to change the subject of an equation, simplify mathematical expressions, sketch equations, and find values of a function at specific points. Thank you very much for listening.